Hello, my name is Mohsin Mohammed and this is my video 4 for Chapter 15, Impulse and Momentum. My setup uses this inclined slide to analyze a perfectly inelastic collision. We have car A with a lighter mass and car B, which is heavier mass, which is stationary at the base. The core question we're asking, what is the common velocity of the two cars immediately after they collide and move together? To establish our model, we start with our video. Car A is lighter mass moving at a speed of 2 meters per second, 2.0 meters per second, calculated from the slide's height, and car B is heavier mass, stationary, which has 0 speed, and hang on. Given the assumptions, we determine the mass of car A, which is 0.15 kilograms. Initial speed of car A is 2.5 meters per second. Mass of car is 0.35. Final velocity, that's what we're trying to figure out. We also assume momentum is conserved because we treat the system as isolated during the brief impact. To solve for the final velocity, we first use. To find final speed, we must model the entire process using conservation of momentum. We begin with the inertia diagrams that shows the transfer of momentum. Initial state, the diagram clearly shows the lighter car MA moving with the speed. Final initial velocity, car B is at rest, meaning its momentum is 0. Final state, after diagram shows the total mass MA plus MB moving together with a single final velocity. Because the collision is perfectly inelastic, the equation we're going to be using is conservation of momentum. Ma times velocity initial plus mass of B times initial velocity equals Ma final velocity mass B times final velocity. Simplifying the initial momentum, we calculate the starting momentum. It's 0.375 kilograms. We're going to be multiplying 0.15 times 2.5, and the term mass B times final initial velocity cancels out because the diagram shows VB is 0. Simplifying the right side, the final momentum, because the diagram shows the car sticks together, we combine the final masses, giving us a total of 0.50 kilograms. The equation simplifies then to Ma times final initial velocity equals mass A plus mass B times initial final velocity. Solution is found, and the initial momentum equation to the final momentum we solve by dividing the momentum by the total mass, and the final common velocity is 0.75 meters per second. Thank you.